Thank you for a nice introduction. Do you see my screen?
Yes, looks good.
Okay, sounds good. So thanks again for a really nice, kind introduction. And I'm really grateful to share my contribution to biomolecular NMR field. Probably you at least heard about Sparky software and then a recent update from the NMRFAM that has been rebranded as NMRFAM-SPARKY. And since I have moved to Denver, you probably might wondering what's going to happen with the Sparky as well. But everything is optimistic, and I'll share my thought, and you can comment on that too. So common testing biomolecular NMR spectroscopy, you probably already know that a top thin or NMR pipe, NMR draw, or NMRFX processor can be used for processing the data after you acquire data from the spectrometers. And then once you process data, making the frequency domain data, you can analyze data. NMRFAM-SPARKY is one of the exemplary software tools. Other software like Keras, CPN, or there are some other tools out there. And then with that data, you extract scientifically meaningful stuff that head towards your research project, or you want to go further, such as a structure calculation. I have my own fully integrated tools such as Ponderosa CS suite, or you probably know about like Cyana or Explore NIS that does its own work. And I'm kind of a promoter of my own software that actually embracing those software tools. So you probably want to know how that goes in the rest of our workshop today. And after you finish your analysis, then you go to BMLB and WWPDB to deposit your data. Then BMLB recently announced a new, really nice updated deposition system called BMLB DAP. You probably want to check out. So NMRFAM-SPARKY does the very basic functions, so such as visualization, picking the signal and determining chemical shift, intensity, volume, line width of the peak. Depending on your protein condition, those observables will be changing. That will be the hint to your biological system. Then you assign those chemical shifts and a signal with the tools that provided by NMRFAM-SPARKY. And other functions such as overlaying multiple spectra, alter the appearance of the spectra. And you can make a nice publishable PostScript file out of your spectra with the labels and contours. Will be a really helpful tool for your publication. And then currently, according to the BMLB statistics in 2020 so far, Sparky is one of the few programs commonly used, 56.2% user share, along with the protein animal depositions, and then followed by Keras and CCPN and ML View. So you can see that Sparky is the most popular software tool for analyzing data. One of the reasons is that it has a long history with a very simple file format, and then a nice addition of automations recently given by NMRFAM and other colleagues. So brief history of Sparky. As I mentioned, Sparky has a long history, originally developed at UCSF. Donald Nella, who was a grad student of Kuntz Group, worked for 6 years to making a very basic tools for visualizing, analyzing NMR, and then Tom Record from the Framing Group at the Computer Graphics Group in UCSF, who now is working with the Chimera and Chimera X, contributed a lot integrating Python. And then I revitalized since 2015 as an official primary developer. Before that, I was an extension developer, integrating my software tools such as Ponderosa and PINE-SPARKY. So that was published in 2015 officially. And then I've been developing new features and updated with improved features. You can download software from PINE NMRFAM, Wix.edu, and download packages.html. And also, you don't really need to install by yourself. You can just connect to nmrbox and then use the really nice features that NMRFAM-SPARKY and other auxiliary tools provides. To get started with the NMRFAM-SPARKY, you probably want to import process data, such as top spin and NMR pipe, grow, and an NMRFX processor will provide the files that you can import into NMRFAM-SPARKY. You can just use command line user interface, such as group to UCSF, VNMR to UCSF, pipe to UCSF. These are the command line user interface. You just open up your terminal and type your input and then space, type your output. And then I provide a new graphical user interface as well. So easy group to UCSF, easy pipe to UCSF, graphical user interface software. Programs will be automatically installed in your system when you install NMRFAM-SPARKY. Again, NMRbox provides these tools by default, so you don't have to install if you're using NMRbox. And also, once you open NMRFAM-SPARKY, and then open the file such as .pipe or .dat, ft2, or 200, 300. If you open those files and then you have proper directory permission to write a file in that same folder, then it will automatically generate UCSF file in the same directory, and then you can just rename it after it converts the file. So it'll be a little bit easier for the one who is not comfortable with the command line interface. And there are some features that I always promote to use for users to just save your time and make your life a little easier, such as setting the Sparky Home. Sparky Home is the working directory. Once you open an NMRFAM-SPARKY and you're starting the new project, you want to set Sparky Home by capital O, capital E, or you can just browse into that function from menu. So go to NMRFAM, utilities, there is a set Sparky Home function there, you set it, and then it's gonna automatically sense a sequence file once you provide it in the same directory where your project files in, and spectrum and pig list and all the files will be branched out from that root working directory that you set. So it will be a lot easier to organize your files. It's not gonna be your files staying all different kind of directories. And then when you need to share your project to somebody else, it's very simple. You can just zip your project folder and then just send it, because all the files will be by default saved as a relative form. So you can just zip and send, and then somebody who receives just unzip it and then open the file. File structure will be remain. So you can just send it, and then somebody who receives can just exactly will have the same condition. So it'll be a lot easier to have it under project that Sparky Home you set. And then another thing is that autosave feature using theoretical PF is also accessible from the main menu, file, and then there's preferences. You select that and then set the backup time. So now you see that I set 5 minutes. So every 5 minutes it auto saves. And after that, you can set the cache size. If you set it so 4 megabytes, it's too small. You can increase it in case you are working with a non-uniform sampling, such as a lot larger than a few gigabyte files that you want to increase a lot. And I'm not sure in our box how much allotted per user, but I think it's going to be fine if you set it 128 or 256. But your performance will be a lot faster than a default. And then setting the sequence is another thing that usually omitted. They just do whatever they want. But I mean, if you set the sequence file, most of the automation tool automatically detect your sequence file in the same directory, because it automatically generates sequence file in the same directory. Let's say your project is a.proj, it's gonna generate a.ploj.seq. So automation tools will determine whether you have that sequence file or not. And in case you have that sequence file, then it's gonna auto load that file. We'll get to that in the hands-on. So file types of Sparky, there are three major file types. Actually, the data UCSF is coming from your raw data. Once you generate UCSF, you will note some metadata, or you will make an assignment and labels, and these kind of information will be saved in that save. And then multiple save files. I mean, the project will have multiple spectra for your project. Usually that project file is .ploj. PLOJ file will contain multiple save files, and then save files, it's going to be one-to-one match to UCSF in general. So if you have some different settings and then save as to other file name, then you will have other save files. But by default, UCSF and save a one-to-one match. And then this is the file structure of NMRFAM-SPARKY. So I mentioned about the Sparky home, where there will be set by you as a root directory of your project. And then you will have branched out directories such as projects, save, Spectra, or lists. So by default, it's gonna be your user home and Sparky, and then it's gonna be the other subdirectories, but you can set it differently, because if you have multiple projects, you wanna separate them out. So you can set by capital O, capital D, or menu NMRFAM and utilities. And like I said, you can set your sequence file by type SQ, and then it's going to generate .seq, just followed by your project file name. So it's going to be automatically sensed and used. And then save files and UCSF files, I mentioned that. Sorry about that. And then if you open reference data, which will tell you the BMLB statistics of chemical shifts, it's going to generate REF directory, and then it's going to have the empty cell files with the labels and lines that will synchronize with your data. So you can place your cursor on and then move your cursor, then you will see the probabilities and histogram of the resonance chemical shifts. And then depending on your analysis, such as iPine automated assignment, PISA-SPARKY, Chaska-Sparky, these kind of automation tools will populate other subdirectories, and you will see the other job ID below this level. And you will have all these kind of data under Sparky Home. So basically you can just, when you need to share, you can just entirely compress the Sparky Home and then ship to somebody else who needs to see your data, such as your PI. So I mentioned about the basic file structure, and then there are basic objects will be in the Sparky. Basically, project is your spectrum. There will be a save file that that will contain all the ornaments, information, labels, and assignment. And the spectrum will contain signals, multiple signals in a one spectrum. And one project will have multiple spectrum that I mentioned, right? And then the spectrum will be contain the view information. I mean, that will be stored in the save file, such as control level. You can change your control level to see different illustration for your spectrum. So you can change the gap between contour lines and the level that you want to cut off as a noise threshold, and also the color of the contours and so on. So that is the basic object: view, spectrum, and project. And then spectrum will have different signal information from your data that will be automatically picked or annotated by yourself. And then assignment will be given to each single peak, and then they will be averaged by the Sparky, and then that will make resonance chemical shifts. And then usually people do not set molecule condition filter, so that's just the undefined. But if you have the data collected in different conditions, you can set molecule condition differently, and then you will have different chemical shifts per your molecule condition setting. Okay, and this is a new feature, look and feel. You can change the color, size of the panel and font, and also the locale is supported. Korean language has been written by me, and then Farsi and Hindi. Mehdi and Eddie are the two postdocs in my group. Will present this workshop later, my talk, and then Hong was an undergrad student under me, also wrote Vietnamese, and Kai Feng, who groups, Huang did a Chinese, and Kumaran is working on Tamil. So I highly encourage you, if you can contribute, please do that. So you can see that color is different. I mentioned that you can change look and feel, so you will see different colors in these screenshots. So menu and pop-up menu, these top parts, once you start your Sparky using, let's say, the icon or software launcher from the NMR box, or you just type the Sparky on your terminal, then you will see this screen. And then top part here is the top menu. Then these are the main menu items that you see. And also in the view, you can right click and then also access all the functions that Sparky provides, such as exactly the same as the main menu. So if you are too lazy to go back to the main menu, or you don't know the two-letter code to launch your function, or if your screen is too crowded to find your main window here, you can just use your right click or control click on Mac. And also command window, if you type something, you will see it here, such as capital capital D was the one that you want to start with to set the working directory, which is Sparky Home. That will be seen here if you type capital D. Anything noticeable from your analysis will be listed in this window as well. And this is the cursor window. So Sparky has the different pointer mode. So depending on your pointer mode, your mouse click and gestures will be recognized differently, such as if you're in the selection mode and then you click one of the item in the view, then it's gonna select. Or if you're in the zoom mode, if you drag certain part in your view, that's gonna be zoomed in for that rectangle that you draw. And also you can add lines and labels and so on. So there are different cursor modes that you can access with your function keys. And well, I will just move to the simple hands-on first, opening the UCSF file. And then I will show you how to change the contour settings and saving the save file first, and then creating the project file. So they are all accessible from the menu or two-letter code that you will be comfortable with. Those two-letter codes, as time goes by, you work with NMRFAM-SPARKY, but still it's also accessible from the menus, and command finder is a new tool that I'm just gonna introduce later. And TreeView is another new tool that I developed recently. So you will see your spectrum listed in one window, and there is a spectrum level and then view level. If you have multiple views for one spectrum, you will have multiple views down here. So two-letter code for looking at this TreeView is TV, and also view list has been there for a long time. Then I improved it to add a search function, and then you can increase the size of the view name here. I mean, everybody complained about the limited size of the view name here, but now it can be expandable by just clicking this just little buttons in the same window. The view list is two-letter code PV. But I mean, you will get used to these two-letter shortcuts, but I mean, there is a new tool called Command Finder CF. So if you don't know the two-letter codes, you can just search your function from there. We'll get to that too. And then spectrum and view settings. I mean, they're all two-letter designated shortcuts, but you can access from the tree view. This new tool, tree view, will allow you to access the view settings. So you select one of them. So if you're selecting spectrum like this, NHSQC, and click setting button here, or just right click on it, then it's gonna open this spectrum setting. So you can rename your spectrum name if you wish, or you can set the molecule condition type, you can compute noise level, and also chemical shift referencing can be corrected in this window too, and also you can put any spectrum description related to this data here. So in case if you want to note something such as a metadata or a pulse sequence you use or anything else you want to note about, then you can just write down here and then click apply. Then view setting window, once you select this view and click setting button, you can access this view setting window. Old Sparky users probably more comfortable with the two-letter code VT. Just type VT, then it's gonna open view setting, and you can access all different kind of functionalities here. And you can see that two-letter codes are all assigned to these functions, but still you can just open view setting and then click one of them. And zoom functions, traditionally ZF, ZI, ZO, and ZU, ZD, Z something two-letter codes have been used for such a long time. But this is 21st century. You can just use mouse wheel instead. Mac users probably will have a problem with the mouse wheel acceleration, but if you use your mouse wheel scroll very carefully, it's still eligible to use. And then instead, you can just use plus or minus. The difference between using ZI, ZO, and plus and minus is that the step is smaller when you are using plus and minus. So you can go a little more in detail in terms of zoom in and zoom out. And also ZU, ZD, when you're looking at the 3D data, you want to look at the a plane down or plane up. Now I mapped the comma in that, which is the same as the greater than and less than key that makes you to move zoom in and zoom down. So it'll be a lot easier to browse across different planes because basically you just tap command that repeatedly is gonna change your plane. And the mouse wheel mode, somebody will like the reverse scrolling direction, or you just want to disable your wheel, just MW will change your mouse wheel mode. And then F11 is the zoom mode that you will zoom into certain range. You already saw that from the mouse cursor window. So this is the quick sheet. You can see it from our NMRFAM-SPARKY user group on Google Groups, or you can just type. I think I think that was SF or something, the two-letter code for opening up that Google group. Um, but you can see it right here. So I met a very Microsoft Office-like commonly used control associated shortcuts. So you can use like Control CV, Control A to select all the peaks. Saving is gonna be the Control S if you wanna open a file, Control O, and then Control P is print and saving a postscript, and Control Alt to replace your assignment. And if you want to find your assignment, Control F will do, and peak size can be Control J, K, and label Control NM. So you don't really need to open your ornament size window to change your peak size and label size if you know that. it is a lot easier to set control level as well. You don't really need to open control level window like before. You can just tap semicolon or single quotation mark. That's gonna change your control level for positive contours. If you wanna change your negative contours, you hold Shift key and press those keys. And then contour line gap can be adjusted by the brackets. So holding Shift key also works for negative contours. So it's going to be a lot easier to manipulate your visualization. And also picking a peak. In the past, you had to change your cursor mode to F8. You can see that this F8 has this icon, that pen icon that indicate you are in the adding a peak mouse cursor mode. But now if you're holding Control key while you are dragging some part of your window or just tap on the certain part while you're in the selection mode, F1, then it's gonna work as the picking a peak. So most of the time, you don't really need to change your mouse cursor mode for that reason. You can just hold your Control key to add a peak. And also in the view, you will see relevant mouse icons indicating what mouse cursor mode you are in. Okay. And then I already mentioned the view settings. You can use white background by just selecting this inverse background color or theoretical CI. Your current cursor's frequency will be seen if you enable frequencies on cursor. If you don't like it, you can disable it. So it's kind of useful tool when you are in street plot, because street plot by default, it does not show your y-axis chemical shift and x-axis chemical shift. So if you turn that on, you will see your current chemical shift. That's going to be really, really helpful when you are assigning your resonances using street plot. And then I already covered how to change your contour level using these semicolon, single quotation, and brackets, using Shift to access your negative contours. But still, if you want to go a little bit more detail, you can use contour window theoretical CT. And that is also in the view settings window or spectrum settings window. We'll get to that. I forgot that. But I mean, you can open it with the theoretical CT. You can change the numbers directly if you wish to change it. But I mean, color spectrum can be accessed from this window. There are more than a couple hundred colors supported by NMRFAM-SPARKY right now. So in case if you are working with the titration data, and then if you want to use same color scheme, different thickness, that will be also adjusted with this contour level window. So moving towards the hands-on, I will open NHSQC file, UCSF directly, and then change white background, and then we'll change the contour, and then suppress noise by resetting the threshold. So I'll change my window to the window without the presentation. I think Adam already copied the file into your home directory. Was that somewhere?
Yes, that's correct. In everyone's home directory, inside that directory there, Woong-hee, I believe you put inside Lee presentations for everyone.
Mm-hmm. So I'm just gonna copy from my home directory, Summer Workshop 2020, Lee Woong-hee ubiquitin _ bbtar.cg to my desktop. And I will untar the file that generates that ubiq_bb/ and the files that you will see. And also all credits should go to NMRFAM's Marco Tonelli, who collected the data and processed the data. This is the data that we typically use for our workshop. You can download even the NMR pipe and I think the variant raw data from NMRFAM download web page. It's gonna be a few gigabytes, but I mean, if you can tolerate the download time, and you can just download and see the raw data. But I mean, this is already prepared Sparky project. I'm just gonna open that UCSF first. I mean, actually, you can use Sparky and type the file name that you want to open, but I'm just gonna go from the scratch, opening the Sparky only, and I'm gonna set the working directory, capital O, capital D. Was right. So animal box, and I copied inside of desktop and ubiq.bb. So this is gonna be my Sparky home. And while the Sparky home will be read when Sparky is being launched, so to make sure I'm loading my Sparky home correctly, I'm just gonna close the program and relaunch it. And if I go file and open, then you will see that by default, it's gonna direct to the ubiq_bb and save. But this time, I'm just gonna open the raw data. So Spectra nhsqc.ucsf, and you see that it has a little bit, I mean, it's already control level settings, not too bad, but there is a little bit of room that you can do a little bit more. So you can see that by default, right now I'm in the zoom mode, but I will change to selection mode because I don't want to be zoomed in every time I click somewhere in NHSQC. So now I'm in the selection mode, or you can just use function 1. And actually, arrow keys will let you move inside of your data. And zoom in and zoom out can be done by ZI and ZO or plus. You can see that step is smaller and zoom out. And I already mentioned about the two-letter code TV, tree view. So the thing that I typed in will be seen here, and tree view is here. I only opened NHSQC, and this is the spectrum level here, and then this is the view level. And then if I select the spectrum and click settings or double click on it, then it's gonna open up the spectrum setting window like this. And then if I select this view and then click setting, and then view setting option is here. So let me just change this window exactly the same as this white background one, and then the contour colors and settings. So I'll just go back to here. First things first, I can change to white background, apply, can see that. And also the contour setting, I mentioned the one-letter code for changing contour level is semicolon and the single quotation mark. So if I click semicolon, right, it's changing. I'm raising my threshold. And if I hit single quotation mark, you can see that the key that I'm pressing here. So I can change like this. And also if I zoom in a little bit, you see a little bit of gray contour, which is from the negative signal. That I don't expect any negative signal in HQC. I want to just suppress them all. Then I can just hold my shift key and then hit semicolon, which makes colon. Then will be completely gone like this, right? And if I want to change the color, then in the view setting, contour setting here, click this guy, and then want to change the positive contour color, right? So there are many colors. I think the color in the presentation might be blue to green. So depending on your signal level intensity, it will apply a different color from blue to green. So I said blue to green. Wait, let me just zoom full ZF to see all signals. Then if I go back to the original slide, you can see that we accomplished the mission that we want to make the same visualization like this one, and then it was that easy. Okay. And then moving towards the 3D, there are two letter codes you can use to change your dimensional order for visualization, XX and XL. XX is transpose, you just changes XY dimension. So you will have Z axis set in here, stay still, only change XY dimension. So typing XX will just change this state. W2 and W3 are in X and Y dimension respectively, and then just type XX will change this and that. Then if you want to change Z axis to the other nuclei, XL rotation. So it's going to rotate all three dimensions. So if you type XL, it's going to go to here, XL to here, XL to here. So it will just rotate the cube. So basic axis order for looking at the solution 3D data is having N15 at the bottom, which is a Z-axis here, and then having X and Y, direct H, indirect nuclei for Y-axis. So the way you do is type XL again and again until you have nitrogen in the Z-axis, and then you will have direct H and indirect C13 or proton in X and Y, and then you just type XX to transpose to make it like this. So that's very simple. And then the command finder is the thing that I already mentioned. So this is a new tool. If you don't know the two-letter codes, or if you want to find the function, you just type CF, and then you just type the function name that you want to find. And even double click on the function that you want to launch will work as the same typing two-letter code. So for example, if you open up the command finder and then search for assign function, and then if you want to open assignment window, you just double click on this item, then it will open this assignment window like this. Oh, I'm sorry. And then peak peaking, I already mentioned that you can change your mouse cursor mode to find and add peak by typing F8, or you can just keep your selection mode, hold your control key, and then drag onto it. I can just briefly show in here. I hold control key, and then drag, then 87 new peaks have been picked like this. And I already mentioned that the change in your peak size can be accomplished by Control K and Control J like this. Okay. And then synchronization can be done by YT. So type YT and then select the axis that you want to make it synchronized. And if you move that synchronized dimensions in one of the spectrum, then other spectrum views will be following that center of your current newly updated position respectively. So it will be very easy to set the, let's say if you're assigning the backbone, you synchronize carbons, and then if you move along C13 dimension, all other spectra will follow your change when you are changing in one view window. And also, depending on data acquisition, spectra referencing could be a little bit off, so you can use AL, aligned spectra. Due to the time limitation, I cannot show everything, but you can go to my YouTube channel, or you can watch NMRFAM's assignment workshop video recordings as well. But I mean, also the user group is there, so if you have any doubts, you can ask too. So this is how a line spectra will go. You select the two signals that you want to say they are identical. So select one and then hold your shift key and then move to the other guy and then select that one too. That will allow you to select two peaks at a time, type AL. Then you say nitrogen and protons should be the same. Select the spectrum that you want to change. So in this case, NHSQC is the reference spectrum, and then according to your NHSQC, H and CCV will be aligned. And if you click align, you will see the chemical shifting amount announced in here in this align spectrum window. Then there are other useful commands that you can use, duplicate the view. So if you want to have multiple views for one spectrum, you can just type VD, and you can just close that view already duplicated by just click X button or type VD. I see Jeff is asking something. Can you unmute yourself and ask?
Yeah, sorry. I was just going to ask, what is the difference between AL and ST for referencing?
Yeah, actually, AL is interactive mode. So you can select one peak in one spectrum window and then another peak in another spectrum window. And then if you use AL to align it, and then if you open ST window for that aligned spectra, then you will see actually the chemical shifted by doing AL. But if you just want to type the number, if you already know uniformly it will change, then you can just type using ST2. So well, there are two methods that you can use. So there are other functions like rename, resonances. Well, this is useful in case if you assign arbitrarily, if you don't know what the assignment, you just make your strips first, and then let's say if you assign such as X100, X101, and so on for the unknown strips, and then if you want to change to M1, V2, F3, then you can use all or control all. And there are other functions like control A, control C, control V, control Z. They are all the same with your common perception to the Office software packages. And these are useful command. And well, I mean, I'll just cover the automated assignment. You probably already know chemical shift assignment that will be covered by Adilakshmi Dwarasal's talk. So I'll just move on how to just run iPine automated assignment system. So it just accepts your pig list, and you just click the button and you get the chemical shift assigned and structures from the CS Rosetta. If you provide nosy data, it will run automated NOE assignment, and 3D structure will be calculated all together. And it's that simple. Like I said, accept sequence and pig list. You can go to webpage i-pine nmrfam.wix.edu, or you can use PINE-SPARKY to plug in from the Sparky. This will be easier method. You just select the experiment that you have and then just click button, then it will assign. And also you can just import the results back very easy using that plugin. And then a Python script is there if you wish to run it manual from the command line. And there is a ipine.py script you can download from iPine web server web page. Then you will you will get a bunch of sufficient reachable data from iPine, including web results recently developed. You will see the NHSQC structure, 2D, I mean the secondary structures and phi psi angles from talus and water exposure and dynamics predictions and cis prolins and disulfide bonds, and they will be all reported in this iPine web page. So this is the web page. You just select the files and click submit button if you're using web interface. And I'll just quickly go to demonstration. I'll just close everything. Open the Sparky and open backbone.proj file. So you can see that they are already synchronized. When I move along the NHSQC, you see HNCACB is following and CBCH is also following. And for things first, command finder, just amazingly, I forgot the 2-letter code to open the automated peak picking. So wanna just type peak, and you see the automated peak picking by Aves software, and sequence files should be in your home directory, desktop ubiq_bb, where I set the Sparky home. So this is the file that I want to load in. And I have NHSQC, CBCH, and HNCACB. 3 experiments are there. And just click Run X. Then it's gonna ask if I wanna run automated assignment after finishing peak picking. I say yes, and I'll just provide my email account to get the results back. So you can be anonymous, but I mean, if you wanna get it in your email inbox, then you can provide your email information. It's doing something, as you can see here. While it's thinking, I'll just move back to the slide. So when I just run Aves, it's gonna automatically run PINE-SPARKY 2. If I wanna do that, you can do stepwise as well. Then, well, I mean, this time I just let it go. And then, well, you can refine your peak quality after Aves is done. But at the same time, PINE-SPARKY and iPine web server is assigning your resonances. Oh, it's already done. So this is PINE-SPARKY 2 automation window. It's already done, submitted the job to iPine web page. Just move to the first workspace. So while it's running iPine web server from the NMRFAM server, I'll just briefly go over the future plan. So actually, I'm working on the next generation software called POKY, with the slogan of POKY and POKY. So it's gonna be more tight integration between Ponderosa CS structure calculation package and a Sparky software. So you can see that PO is here and then KY is. So that's the reason behind the naming POKY. Then it's gonna have a tighter integration that I said, and then it will be the modernized features. Their Qt5, Python 3, and new data format, and large data sets will be more freely supported. And then parallelization will save your time. One of the new functionality, I mean, the Python script that will be in the POKY software is multi-threaded peak picking software called ipic.py. It's already there, and then it's going to be integrated into the POKY software. And then other machine learning and metabolomics and so on that will be all integrated in the POKY software. And then one of the new direction towards these development is, you can see it from the CHESPA Sparky software for allosteric network mapping. That was collaboration between our group and a Melacini group from McMaster University. You can go to sites, google.com, view CHESPA Sparky. It has video tutorials and software explanations in a very detailed, and you will see that the user-friendly graphical user interface is already developed there. And then it will be coming to NMRBox very soon. Then I hope to extend it to the other similar applications such as the dynamics or concise method. And then there is a solid state NMR version developed from the McDermott. So that will be all in my consideration. So already have a like a mock-up screenshot here. This is POKY, this is the POKY and POKY, and this is the side panel that already integrated to view here. And then you see that importing will be a lot easier from the Bruker and NMRPipe and variant and so on and so on. And then POKY structure builder will open up the POKY structure builder window here. You just select your sequence and chemical shift and noisy data or some other restraints, not only NMR, it can be SAX data or cryo-EM data, and other restraints such as disulfide bond and cis-proline will be automatically detected based on your chemical shift. And you can just click the calculate button, will give you the structure, very easy. And I actually got my email that assignment has been done. So I'll just quickly go over these Chaska new allosteric network mapping software. So you can just go visit that URL that I provided with, in earlier my talk, and it has a computer vision and AI features, doing PCA, using your chemical shifts, and it will map allosteric networks, and it will be very useful tool using multiple chemical shift perturbation experiment. And yeah, again, this is the web page that you want to visit. There's video tutorials, how to set up, how to visualize your data, 2D plots, and also it will be mapped onto your PyMod 3D structure. And also example data is also provided from this web page. And other useful resources, most of the work that I have been worked also has a tight relationship with not only NMRBox, but also NMRFAM assignment workshop. You can watch all the videos from NMRFAM virtual assignment workshop page from their web page. They are freely providing those videos recorded by the staff members there, along with myself and Maddie, who's my postdoc, who will present the integrated structural biology this time. You can download software and then data from their download page. And then also you can just watch all the video clips from the YouTube. nmrbox.org is the page that you access NMRbox and the software package that I provide. And there is a user group in Google Groups. And then data using this talk is in here. So you can just copy over and then test yourself. Let me just go over to the PINE-SPARKY 2 window. So I have this key code assigned. Let me just check the results. It's gonna ask, yeah, it's already done. So you can see that it's finished. I can just say, okay. Well, 2D, I mean, secondary structure prediction is here. Chemical shift assignment quality is here. And then a chemical shift referencing. You see that offset is only 0.07, and hydrophobic predictions, the red indicate it's buried inside the core, the blue indicates it's exposed to the water, and then dynamics information from random quality index. You see that some parts are a little more dynamic than the other part. Then you can import the assignment onto your project, just clicking the OK button then. Yeah, so you have all the assignment based on iPine web servers results like this. And I'll take any questions. I I have been using a little bit more time. I will defend myself because Adam's introduction was really nice and it took a little bit, few minutes of mine. So I'll take questions. Thank you.
Thank you, Woong-hee. That was awesome.
I just have a question about your future plans for your software.
Well, yeah, I support NMRFAM-SPARKY as well from the Google groups. So please, I mean, I get a lot of personal emails, multiple emails every day, but it's really hard for me because I need to answer the same questions over time and over time. So if you ask questions using Google groups, that will be helpful for others as well. So I highly recommend using Google groups. And so software-wise, it's gonna be in parallel at this point because new modern systems will allow to run POKY because POKY has all modern features. But I mean, the servers, such as the servers in NMRFAM, they will not be able to run POKY unless they upgrade the operating system. So I also consider that. I will be, actually I'm an external collaborator of NMRFAM. So my contribution will partly going towards NMRFAM-SPARKY as well as for maintenance and then a few new developments. So that's our plan.
I was particularly interested in if this software would be compatible with Mac software. OS X Catalina has been causing no end of problems with lots of software recently.
Well, I don't have any problem with the Catalina. So, well, we recompiled everything for Catalina, so you can just download. If you want to run local, you can download from NMRFAM software download page, Mac version, and it will work as the same. Actually, I'm using Catalina, and then there is no problem. But I mean, if you use nmrbox, you don't really need to care about those kind of problem. I would say that will make Adam happy.
Thank you.
I think that's about it. I'm just gonna unshare my screen.
May I ask one real quick question?
Yes.
Yeah, so you mentioned using NMRbox. Are the current iPine servers and things running on Box, or is that just at NMRFAM?
Oh, those servers are running on NMRFAM, and then NMRFAM-SPARKY on NMRbox submit a job to NMRFAM servers.
Okay, so those guys are linked through APIs and stuff, so everything works.
Yep.
Cool. Thanks very much.